As humans, we're well aware we need water to live. Fortunately for us, we live on a water planet. But that doesn't mean we have an entire globe of H2O to use as we please. So just how does the usable water break down for us? A giant 97% of Earth's water is in the ocean, so we can't use that. 3% is fresh water, but even in that small sliver, about 2% is locked in glaciers, ice caps, and groundwater. That leaves about 1% of the fresh water on Earth that is accessible and usable by humans. Let's imagine all of that accessible fresh water fits into this tiny pool. Now we'll get to some small numbers when we look at global freshwater. There really is a small fraction of usable and accessible freshwater on this water planet, so how do we use that tiny pool? In the United States, about 49% is used in thermoelectric power production, while agricultural irrigation makes up about 31%. 11% goes to public use in our cities and towns, 4% goes into industry and manufacturing, and 1% is domestic use. The water coming out of our faucets largely comes from precipitation. Measuring how much or how little precipitation falls can impact how we live our daily lives. Elsewhere around the globe, in developing countries, agricultural irrigation accounts for about 70% of freshwater use, while industrial use is 20% and 10% for public consumption. In places where access to usable freshwater is greatly limited, knowing when and where precipitation may fall is critical to livelihoods. Precipitation replenishes these tiny reservoirs of fresh water, and data from the Global Precipitation Measurement Mission will help farmers, ranchers, and policymakers in these regions plan for periods of drought, flooding, and other extreme weather.
If we measure the Earth from the ground, we can get a good local picture of what is going on around us. But if we want to measure larger portions of the Earth, then we'll need to use remote sensing. Remote sensing measures the Earth and its features without making physical contact. We can gather data from entire continents over longer time periods so we can look at how the Earth is changing. NASA uses specialized aircraft and sophisticated satellites to gather data using both passive and active remote sensing methods. Passive remote sensing measures the natural energy or radiation of the Earth. Active remote sensing gathers data by actively sending out signals that interact with the target of interest. Using both active and passive remote sensing techniques, NASA can look at soil moisture maps to monitor drought, estimate snowpack in areas where snow is crucial for freshwater, measure the change in ice sheets and sea level, tracking storms that could impact human lives, and observing how precipitation changes affect where we get our freshwater. The Global Precipitation Measurement Mission helps fill in the gaps where ground measurement isn't enough. Places with rugged terrain can block the signals from ground radars. The oceans are too vast to cover with enough ships and measurement stations on the surface, and places without the network of instruments needed to measure freshwater for people and agriculture. We can then unify the measurements to create a consistent and accurate picture no matter where we are. Because satellites get more complete coverage than ground-based instruments, we can use remote sensing to better see how the whole Earth is changing over time. With a long data record, we can make better predictions about the water cycle, the climate, and the impact on humans. By observing our Earth from above, we get a much better understanding of what is happening on the surface, in the atmosphere, underground, over the globe, and in our own backyard.